What is a series? We're trying to capture, with some precise mathematics, an intuitive idea. I've got a list of numbers. I'm imagining that I want to add up all of these numbers. But the list goes on forever. Well, I could just start adding. Here's the first number, plus the second number, plus the third number in my list. And just start adding up all of the numbers in my list. But if I'm really going to add up all of the numbers, I'd never finish. So what am I supposed to do? We'll use partial sums. What's a partial sum? Well, instead of trying to consider this series where I add up all of the a sub k's, right, with this infinity up here, I'm instead going to consider the partial sum. I'm just going to add up the first n terms of this sequence, and I'll call that s sub n. Let's see this a bit more concretely. So if I wanted to calculate, say, s sub 5, the fifth partial sum, well, I would just add up the first 5 terms of my series. I'd add up a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. If I wanted to calculate s sub 7, the seventh partial sum, well, I'd be doing the same thing, but I'd be adding up the first 7 terms of my series. This is potentially a very confusing point. I've got a sub k's and s sub n's. I mean, I started with the sequence a sub k, and out of this sequence I built the series, and from this series I then started considering another sequence, the sequence of partial sums built out of this series, which was itself constructed from this sequence of numbers. So why is this sequence of partial sums useful? Well, here's why. I want to add up all of the terms in the series, but I'll never finish that task. So instead, the partial sums are telling me just to add up a lot of the terms. S sub 2 is just the sum of the first 2 terms, which I could compute. Then I could compute the sum of the first 3 terms, S sub 3. Then I could compute the sum of the first 4 terms. I could compute the sum of the first 5 terms. I could compute the sum of the first 6 terms. I could compute the sum of the first 100 terms, the sum of the first 1,000 terms, the sum of the first 1,000,000 terms. And if I add more and more terms, hopefully I'm getting closer and closer to what would happen if I added up all of the terms in the series. The trick then is to take a limit. I'm never going to finish adding up all of the terms, but I can add up lots and lots of terms and see if I'm getting close to anything in particular. Here's the official definition. If I want to add up all of the numbers in my list, all of the a sub k's, then I'm going to take a limit of the partial sums. I'm going to take the limit of adding up the first n terms in my sequence. There's a bit of terminology to introduce. If the limit of the sequence of partial sums exists and is equal to some finite number L, then we say that the infinite series converges. What if the limit doesn't exist? Or what if the limit is infinity? If the limit of the partial sums doesn't exist, or it's infinity, then I say that the series diverges. All of this is setting up the basic question that'll occupy us for the rest of this course. Given a series, does it diverge or does it converge? And if it converges, what does it converge to?